Dear students, today we shall discuss the next part of the chemical kinetics. It is a continuation of the last class where I have discussed the fundamentals of chemical kinetics about the rate, order, molecularity, and difference between rate and order and molecularity. And we have derived an expression for reaction rate constant of second order reaction when two reactants are same. So today's presentation is on derivation of expression for rate constant of second order reaction with A not equal to B. And after this we shall see what is Arrhenius equation and what is its importance. Alright. So now let us consider two reactants A plus B which are different from one another, which gives rise to a product. Suppose the initial concentrations of A and B are small a and b respectively. The after time t, say x moles of reactants A and B are reacted. So therefore, the remaining concentrations of A and B after time t may be A minus x and B minus x moles per liter respectively. So according to the law of mass action equation, rate of reaction is proportional to concentration of the reactants raised to some power. Okay, so therefore obviously rate is proportional to concentration of A into concentration of B. Therefore dx by dt is proportional to A minus x into B minus x. So therefore dx by dt is equal to A minus k into A minus x into B minus x, where k is the reaction rate constant of second order reaction. So from equation, if you reorganize this, you will going to get dx divided by A minus x into B minus x, that is equal to k into dt. Upon resolving the left hand side by partial fractions, you are going to get 1 over A minus B into 1 divided by A minus x minus 1 divided by B minus x into dx is equal to k into dt. So now if you want to get the reaction rate constant, we have to integrate equation 3. So when we integrate equation 3, we will get 1 divided by A minus B into integration of dx by A minus x minus of integration of dx by B minus x, that is equal to kt plus a constant c. Now what is integration of A minus x? That will be log of A minus x. Integration of B minus x is log of B minus x. Integration of 1 over A minus x is log of A minus x. Integration of 1 over B minus x is log of B minus x. So therefore the above equation becomes 1 by A minus B into minus of log B minus x plus log A minus x, that is equal to kt plus c. So when you reorganize this equation, you will going to get 1 by A minus B into log to the base e A minus x divided by B minus x, that is equal to kt plus a constant c. Now at the time t is equal to 0, obviously x is equal to 0. So therefore from equation 4 we will get c is equal to 1 by A minus B into log A by B. Okay, now we substitute for c in equation 4, we will get 1 by A minus B into log to the base e A minus x divided by B minus x is equal to kt plus c is what? 1 by A minus B into log A by B. So therefore again if you rearrange this equation, you will get kt is equal to 1 by A minus B into log A minus x divided by B minus x minus of log A by B. So therefore this becomes 1 by a minus b into log b by a into a minus x divided by b minus x. So therefore k is equal to 1 by t into 1 over a by minus b into 2.303 of log to the base 10 of b into a minus x divided by a into b minus x. So this is a final expression for reaction rate constant of second order reaction when two reactants are different. Hope you understood this simple derivation. So if you have any doubts, you can ask me later. Now let us see what is Arrhenius equation. This was an important equation to find out the activation energy, which was given by Svante Arrhenius in 1899. He combined the concepts of activation energy and Boltzmann distribution law into one of the most important equations in physical chemistry. And the Arrhenius equation is given by K is equal to A e power minus Ea divided by RT, where A is Arrhenius constant or pre-exponential factor, and Ea is the activation energy, and RT is the average kinetic energy. So what is activation energy? It is actually the minimum energy that is required to bring about a chemical reaction. So K is equal to A e power minus Ea by RT. Now when you take logarithm on both sides, ln K is equal to minus Ea by RT plus ln A. Now if you plot a graph of ln K versus reciprocal of temperature, that is 1 by T, we get a slope of Ea by R, that is minus of Ea by R, and intercept as ln A. Now if you differentiate equation 2 with respect to temperature, you will get d ln K divided by dt is equal to minus Ea divided by RT square, that is Ea by RT square. Now integrate this equation, that is d ln K divided by dt is equal to Ea by RT square. If you integrate this between two temperatures T1 and T2 and rearrange the equation, we will get ln K2 by K1 is equal to Ea by R into T2 minus T1 by T1 into T2. This is an important integrated Arrhenius equation from which we can calculate the energy of activation by knowing the rate constants at two different temperatures. Okay, that is ln K2 by K1 is equal to Ea by R into T2 minus T1 by T1 T2. So if you know this equation, you can calculate the activation energy by knowing the rate constant at two different temperatures. So we shall stop it here, and we shall discuss the remaining aspects in the next class. So you can go through these textbooks, that is Physical Chemistry by Bal and Bal and Puri Sharma Pathania, and textbook of Physical Chemistry by K.L. Kapoor, and Reaction Dynamics by Upadhyay, and Physical Chemistry by A.S. Negi, and Chemical Kinetics by Leidler, etc. You can go through these textbooks. Thank you very much for watching this video.